Hello students, in this video we will discuss about the graph of quadratic function. Here you can see three forms of quadratic, in which first form is known as quadratic expression and this is known as quadratic equation, and third form is known as quadratic function. There are the basic difference in expression, equation and a function. An expression have no graph, equation have generally a linear graph, like the if we have find two value of x, then we get only two lines on a Cartesian plane. But in case of function, every function have a unique graph, just like the graph of quadratic function. The graph of quadratic function on a Cartesian plane is known as parabola. So we can say that the graph of a quadratic function is parabola. The graph of quadratic function is called parabola. Again, I want to tell you that graph of every function is always unique. So the graph of quadratic function is a parabola, but when anyone asks about the graph of equation, it is not unique graph, because in case of equation we can find two exact value of x which draw a line on a Cartesian plane. Okay, so if we will discuss about what is a parabola, so the shape of a parabola is just like U shape. It is U shape on a Cartesian plane, like this or like this. What is the difference in both type of graph? This is known as opening upward parabola. This is known as opening upward parabola, and this is known as opening downward parabola. Opening downward parabola. How can we identify when a graph of a quadratic function is opening upward parabola or opening downward parabola? As we know, the form of a quadratic function is like fx is equal to ax square plus bx plus c. If the coefficient of x square is positive, it means the value of a is positive, or we can say it is more than 0, then the graph of this function is from opening upward parabola. But in case of downward parabola or opening downward parabola, the value of a, it means the value of coefficient of x square is less than 0 or negative. So in this case we get opening downward parabola. Okay, I think you have got it. When the function have opening upward parabola, when the quadratic function have opening downward parabola, it is totally depend on the sign of a. It means the coefficient of x square. If the coefficient of x square in a quadratic function is positive, then we get opening upward parabola. But if the sign of a is negative, then we get opening downward parabola. Clear? Every quadratic function have two values for which a function is equal to 0. These value of x is known as zeros of function. But in case of equation, these value known as roots of equation. Suppose if we have a form of quadratic equation ax square plus bx plus c is equal to 0. So for this form, the value of x for which this equation is equal to 0, in this case the value of x for which this equation becomes to 0 is known as roots of equation. So here we can say the value of x for which equation is equal to 0 is known as roots of equation. Roots of equation. Suppose here we take an example x square plus 7x plus 12. If we simplify or factorize, we get x plus 4 and x plus 3. So if we put the value of x is equal to minus 4 or x is equal to minus 3. These two value of x is known as roots of equation. This is known as roots of equation. Okay, but if we write this form in a function form, fx is equal to ax square plus bx plus c, and again we have take this example x square plus 7x plus 12, and again we have factorized it, then we get the factor like the equation x plus 4 and x plus 3. Again if we put, yeah, we replace x by minus 4 or minus 3, we get the value of function is equal to 0. So which value of x, which values of x for which fx is equal to 0 are called zeros of function. Zeros of function. Every quadratic equation or quadratic function have only two values of x, because as we know the value of zeros, the number of zeros or the number of roots depend on the highest degree of given polynomial. So in every quadratic equation or quadratic function, the highest degree of x is 2. So we get only two values. Okay. And again here another point that is known as discriminant. Every equation or every function of quadratic have a discriminant that is represented by d, and the value of d we can solve by the relation b square minus 4ac. Here b is called the coefficient of x and c is constant term and a is the coefficient of x square. If we get the value of d is equal to 0, then we say that zeros are real and equal. If the value of d is greater than 0, then we say zeros are real but unequal. If the value of d is less than 0, then we said imaginary zeros. Why we have find this nature of roots? Because this nature of roots define about the graph also, that when a graph of a quadratic function cut the x-axis at 2 point, at 1 point, or none of any point of x-axis. So as it will be more clear by taking an another example. Suppose we have an quadratic function like fx is equal to x square plus 5x plus 6, and if we have factorized in linear form, then we get the factor x plus 3 and x plus 2. As we know very well that if we replace x by minus 3, we get the function is equal to 0, and if we replace x by minus 2, we get the function is equal to 0. Here we can replace fx by y, so it work as a ordered pair. So if we replace x by minus 3, we get an ordered pair minus 3 comma 0, and if we get to replace x by minus 2, we get another ordered pair that is minus 2 comma 0. But if we replace x by any other value that is 1, then we get the value of polynomial, that is 1 square 5 into 1 plus 6, that is 12. Okay, if we replace it by minus 1, then we get another value minus 1 ka square plus 5 into minus 1 and 6, 1 minus 5 plus 6, and here we get the value of 2, and so on values. Okay, if we replace this by minus 3, then we get the value of, so sorry, it for minus 3 the function is equal to 0. So here we get two value for which y is completely 0. So if y is completely 0, then we say that these 2 points lie completely on x-axis. Okay, then we say that these 2 points lie completely on x-axis. Here we take an graph, that is y, that is x, as we know very well, the points where x, for which value of x y is completely 0, that is minus 3 and minus 2. It is completely left hand side from the origin. So minus 1, minus 2 and minus 3. So it is completely 0 for minus 3 comma 0 and minus 2 comma 0. But for the value of minus 1, it is equal to 2. So minus 1 and it is equal to 2. So the point is here minus 1 comma 2. And for 1, for the value of 1, it is equal to 12. That is 1 and it is equal to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 and so on. Say here like this. Okay. If we take the value of x, that is minus 4, so we get the value minus 4 cow square plus 5 into minus 4 plus 6, that is 16, minus 20 and plus 6, that is 22, minus 20, that is 2. So again we get a value at minus 4, that is 2, like this. If we join these points by free-handed, then we get the shape of this quadratic function like this. As you see, the shape is like a parabola, like a U. How can we say that it is opening upward parabola? Because here you can see in this function, the coefficient of x square is positive. If it is negative, then we get a shape of parabola in opening downward. Okay, again, the point is, how can we identify that it cut only 2 points? Because the value for which the value of x which makes up function is completely 0. These are called zeros of the function. Here y is completely 0. So these 2 points lie completely on x-axis. So if the value of t is greater than 0, if we find the discriminant of the given function, that is fx is equal to x square plus 5x plus c. Here if compare this ax square plus bx plus c, then we get the value of a is equal to 1, b is equal to 5 and c is equal to 6. And we identify d is equal to b square minus 4ac, b is 5k square minus 4 into 1 into 6, that is 25 minus 24 is equal to 1. Here d is equal to 1, it means d is greater than 0. So in case of d is greater than 0, cut x-axis at 2 points. Okay, again, if d is equal to 0, then graph of quadratic function, the graph of quadratic function cut x-axis or touch at only 1 point, at only 1 point. If d is less than 0, then it is completely it is completely it is completely below the x-axis or above the x-axis, or above the x-axis. It means when the roots of a quadratic function are imaginary, it never cut the x-axis at any point. If d is less than 0, then we get the graph like this, completely upward or completely downward. Never touch x-axis at any point in case of when d is less than 0. If now in this case we define 2 points like d is less than 0 and a is more than 0, because it is opening upward parabola. In this case, we define that d is less than 0 and a is also less than 0 because it is opening downward parabola. If d is equal to 0, then graph we get of the function is always touch x-axis at only one point. In this case, we say that a is greater than 0 and d is equal to 0. Or second case, it will be like this. It touch only x-axis at only one point. In this case, we also define that d is equal to 0 and a is also less than 0. But in case if d is more than 0, it means d is greater than 0, then we get a graph of quadratic function which cut the x-axis at 2 points like this or like this. Here we also define 2 points, that in this case d is greater than 0 and a is also greater than 0. It is opening downward parabola, so d is greater than 0 because it cut the x-axis at 2 points. D is greater than 0 and a is also less than 0 because opening downward parabola. These 2 points, how can we point out? It means this is called origin. From left side of origin all the points are negative, from right side all the points are negative, positive. So we can say in this function one roots is positive, one roots is negative, one roots is negative, one roots is positive. If it's completely from left side, then we said that both roots are negative. It is completely shift right side of the origin, then we say that both roots are positive. Again, here we also determine some points, that in this case we say roots is positive. If the graph is like this, so we can say roots is negative. If the graph is like this, then we say roots is negative, roots is positive. Clear? And in this case both roots are imaginary, so it never touches the x-axis at any point. I think you have got it. The graph of parabola, how can uh, s- uh, how can it reflect too many points by identify the graph. Okay, I think you have got it about more about the graph of parabola. Thank you.